Hey, welcome to Variables. Today we're going to learn about not just what a variable is, but all the different parts of the things that we need to know about it. So as we go about learning about variables, I'm going to start off with a question that doesn't really seem related, but it'll come back to be meaningful in the end. So if you look at this box, right, you've got an A, and then there's nothing else in the box, right? So the first question I'm going to ask you is, what is the number of A's in the box? So obviously the number of A's is, I'm going to start over now. Hey, welcome to Variables. This is going to be a lesson where we not only talk about what variables actually are, but all the different parts and things that you see. It's really a lot more vocabulary than it is actually just kind of traditional math, but that's okay. We're going to start off today by asking a question which seems a little different, but it actually just come back to be meaningful in the end. How many A's are there in the box? Well, it seems like a pretty obvious question. The answer is 1. There's 1 A in the box. Second question, how many B's are in the box? Well, I got an A, there's nothing else in there. So what is the number of B's? There are 0 B's. I guess that'll come back to be meaningful in a little bit. I scroll down, I see this, and we'll come back to this in a second. First thing I'm going to do is a couple of definitions. My first definition is variable. A variable is defined as a letter which represents a number. A letter that represents a number. Now sometimes it's going to have an assigned value, and we're trying to figure out what is the value of the mystery number. And you're going to have to do some work to try to solve it. But just in general, a variable is a letter. A coefficient is a number. A number which is multiplied by a variable. The last term is a constant. A constant is a number which cannot vary, right? It never changes. No matter what x is, if x is 2, if x is 3, if x is 4, if x is 5, it never ever changes. So we'll see that here in a second. Let's go back up and let's look at the part that I just skipped. Right here I've got 2y equals 3x plus 4. So what is 2? That's the first question we're going to have to ask ourselves. 2, well, you know that 2 is a number. So you have the choice of coefficient or constant. That's your only two choices. So which one are we going to choose? Well, coefficient, whenever I think coefficient, I think a number, and it has to be attached to a letter. Constant, a number not attached to a letter. So as I do this, 2 is attached to y, so it's going to be a coefficient. I'm just going to abbreviate COEF so I can save some space. Y. Well, y is a letter, so that makes it easy. I know it's got to be a variable. Okay? 3. Well, once again, it's a number. I ask myself, is it attached to a letter? Yes, it is. It's a coefficient. Right? X. X is a letter, so therefore I know that it automatically has to be a variable. Right? The last thing is plus 4. Once again, I have a number. But is that number attached to a letter? No, it's not. It's not attached to a variable, so it's a constant. Okay. We also talked about expressions, right? An expression is what you see right here. 3x plus 4. That's an expression. 2y is an expression. The difference between an expression and an equation is one very, very, very important thing that makes an equation an equation. It's this sign right here. It has an equal sign. Has an equal sign. So as I scroll down, we're going to practice, and some of these seem pretty obvious. 1 and 2 are pretty obvious. 3, 4, 5, and 6 have a little bit of a curveball. So if I look at number 1, I see blank, or I see A is the blank. Well, A is a letter, so I know that it's got to be the variable. Right? 12 is the blank. Well, 12 is a number. Is it attached to a letter? No. So it's got to be a constant. On number 2, 3 is the blank. Well, it's attached to x, so it's a coefficient. X is the blank. It's a variable. Right? And 4 is the blank. 4 is a number. It's not attached to x, so it's a constant. Okay. On number 3, I see 34x minus 8. So here's what the most common thing to do here is. Blank is the constant, 8. Blank is the variable, x. Blank is the coefficient, 34. Right? Now, this is actually not totally correct. A constant, like I said, is something that never, ever, ever changes. So if I talked about if I said x is the height of the people in this class, sometimes x is going to be really high with tall people, sometimes x is going to be really small with short people, but it's going to change up and down. X varies, right? But if I dig a hole, and everybody steps into a 1-foot hole, and then we measure everybody's height, right? The height's still going to vary. For some people, they're still going to be tall, and they're still going to be short. But the difference is everybody's height is going to decrease by 1 foot. Right? A constant is something that affects everything the same way. Well, if I added height, I would have to actually show that I added it, like I have been. But if I decreased, I'm not going to say that 8 is my constant. I'm going to say negative 8 is my constant. I have to make sure that I show that it's 34 times x and then decreased by 8. I look at number 4, and I see this. I see blank is the constant. Now, tricky thing here is that now I have 2 variables, and I have 2 coefficients. So blank is the constant. Once again, it's easy to see. It's negative 4. What is the variable? Well, now I have 2 variables. I've got x, and I've got z. I have to list them both. If I don't list both of them, I'm wrong. I haven't finished the problem. What is the coefficient? The coefficient is going to be the numbers in front. So what's in front of x? Negative 3. What's in front of z? 2. Okay. On number 5, I see negative 6x squared plus 4. Here's the temptation. What's the constant? 4. What is the variable? X squared. What is the coefficient? Negative 6. Right? That's what the majority of people will tell me in the middle of this lesson. But we're actually not quite right again. Here's why. I defined a variable as a letter which represents a number. Okay? It is a letter. Last time I checked and I went through my ABCs, x squared was not a number. A, B, C, D, E, F, G, blah, 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 blah. X squared. X squared was nowhere in there. It wasn't after x. It's not in there at all. So my variable isn't x squared. It's just x. X is my variable, not x squared. Okay. Last question, 6. I see z. Right, so I've got what is the constant, what is the variable, what is the coefficient. I'm going to start off with the variable because it's easy to answer. I've got z. Done. What is the coefficient? What is the number in front of z? Well, let's go back up to here. I asked the same question here. How many a's are there? And I said there's 1 a. Even though I didn't say there was 1 a, I knew that it was going to be true. So if I start off with some apples in my hand, and I have 5 apples, and then I have 4 apples, and then I have 3 apples, and then I have 2 apples, and then I have an apple. Right? In the English language, I can take anything, and if once I get to 1, I don't have to actually say I have 1 apple. I don't have 1 marker. I have a marker. I have an apple. When you get down to singulars, you don't actually have to say the number. It's implied. Same thing happens in math. There's only 1 a in this box, so it's understood that there's a 1 in front. So as I come down here, there's only 1 z. It's implied that it's singular. So what is the coefficient? It's an understood 1. So right here, if we scroll up a little bit, I had negative 3 x's. I had 2 z's. Pretend it's an item. I had 2 of them. Right here I only have 1 z. The last part is, what is the constant? Well, whenever I try to figure out what the constant is, I need to think about what's the number that doesn't have a variable. Well, there's no numbers in this. So what do? I scroll up, and I answer the same question I did here. What was the number of b's? When you look at the box, you go, well, there's an A. There's nothing over here. There's no b's. But you know in real life, when you say nothing as a number, you know that that number is 0. But for some reason, when we start transferring to math, we totally forget what we were just talking about. So if I look over here and I say, I've got z, right? What is the constant? The constant is the thing over here. The number that's not multiplied by a variable. There isn't one. So how would you say there is none as a number? The number is 0. Right? Z is not modified positively or negatively. Let's move on to the next problem. I see negative 2x squared y to the third. Right? Now this is a problem that it's not overly hard, but I realized whenever I was looking at it that if I didn't actually show you one of these, that it would seem a lot harder than it is. Negative 2x squared y to the third. Well, I know there's an understood times right here, and there's an understood times right here. Negative 2 times x squared times y to the third. Now another way that you'll see this asked on your homework is, what is a way to write this without an exponent? So I'm going to say negative 2 times x squared without an exponent. It's going to be x times y times y times y. Now, one of the biggest temptations with a problem like this is that people want to square negative 2. So they go negative 2 times negative 2 times x times y times y times y. No, you got to be careful. The exponent only applies to things directly before it. So the 2 only applies to x. The 3 only applies to y. When I go to evaluate my expression on the 7th problem, I see negative 3rs to the third. Well, negative 3, I know what that is. Alright? And then r, and then s to the third. But r is something and s is something. So as I go to do this, I'm going to plug in negative 5 for r, and I'm going to plug in negative 2 for s. Now, how did I know that I was supposed to put this in parentheses? Because I know from my exponents lesson that if I don't put it in parentheses, it's going to totally change it. S is being cubed. It's being raised to the third power. Is s negative? Yes, it is. So if s is negative, then I'm going to raise the negative to the third power, because it is a part of s. So this becomes negative 3 times negative 5 times negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. I multiply those all out and I get negative 120. Okay. Last problem has to do with the question, when am I ever going to use this in real life? Because I get that question all the time, and here's an application of it. When you were in my class, 4Q1 plus 4Q2 plus 2M divided by 10 represents your semester grade. That's true. That's how it works here at Parkview. And so when you hit the coming up on Christmas or coming up on summer, you want to figure out what grade do I need to make on my final exam to maintain a B, to maintain an A, to maintain a C, whatever grade you want to maintain. You want to figure out, if I do this, what's going to happen? Well, this is how we're going to do it. Right, so keep this in mind for whenever we hit December, and you want to go, what do I need to make on my grade to do such and such? This is how you're going to do it. It's pre-algebra. So you make a 95 in the first quarter. You make a 92 in the second quarter. So you worked really, really hard both quarters. And then you go, you know what? I did so well, I bet I could not even study for this exam, and I'm still going to make an A. And then you made a 60 on your midterm, so that's not good, right? The question then is, did you keep your A? So in order to figure out if you kept your A, I'm going to need to stop and actually plug all my numbers in. 4 times Q1, and I know Q1 is 95, plus 4 times Q2, and I know Q2 is 92, plus 2 times M, which is 60, all over 10. Now, maybe 2 or 3 weeks ago, you would have sat here and said, 4 times 95 is 380, and I know that to be true. 380 plus 4 is 384, times 92 is some huge number. But now you know better. Now you've been through order of operations. You know that I need to multiply here, then I need to multiply here, and then I need to multiply here, and then I need to add them all together, and after I do that, then I divide. So 380 plus 368 plus 120, all divided by 10. 380 plus 368 plus 120 adds up to 868. You divide it out, 86.8. So did you keep your A? No, you didn't. You worked really, really hard For 17 weeks, you made a 95 first quarter, 90 second quarter, you blew off the midterm, and it actually hurt you, made you drop your A. So what's the moral of the story? Don't quit. That midterm exam is super, super, super important. It's the most important test of your semester, both in the fall, and then your final exam is the most important test in your spring. And it's going to affect your grade pretty good. So make sure that you don't quit up until that point. Now obviously I'm going to get you ready for it. We're going to walk step by step through. But I just want to throw that out there as a cautionary tale so that you do not quit before you get to the finish line. So anyway, that's our lesson on variables. I hope that it was helpful.